Alright, geometry 3-9, proving parallel lines. We are going to use some of the concepts that you learned in an earlier section about angle relationships in this unit. So you might want to also reference that as well. We have our theorems here that you will be using to prove as reasons for your proofs. Alright. So let's identify parallel lines. So we have figure. It's quite the figure. It has lots of stuff going on. So we are going to, I'm going to do this in a couple different colors so we can differentiate what we're talking about. Alright, so we were talking about first angle 2 and angle 8. Now, angle 2 and angle 8, they touch the transversal L, and they have parallel lines A, B. Now, with parallel lines A, B, and transversal L, that makes them alternate interior angles. All right? So, angle 2 and angle 3 are alternate interior angles, and again we learned about these angle relationships in a section called angle relationships. You're definitely going to want to reference that. Alright, so lines A and B, okay, they're alternate interior angles because angle 2 is congruent to angle 8. Angle A is parallel to angle B by the alternate interior angle, converse. Alright, you'll notice the relationship name is right in the name of the reason or the theorem. You can read more about the theorems up here. Alright, now let's check out B. Okay, I'm going to switch colors. We're gonna do blue. That will show up nicely. Alright, angle 3. Okay, angle 3 and angle 11. This time A is the transversal. Alright, and L and M are the parallel lines. Well, where A and L cross makes an X, alright, lower right, and where A and M cross, okay, lower right, so they are in the same corresponding location, so these are corresponding angles. Oops. There's an L there. Alright, angles of line L and M because angle 3 is congruent to angle 11. L is parallel with M by the converse of the corresponding angles theorem. Oops, there's an H. Boop. Alright. Now let's see. I guess I'll do black to go over the two lines I already have. Oh, no, maybe red. Let's do red. Alright. So angle 12 and angle 14. Okay, so angle 12 and angle 14. Okay, the line that touches them is M. Alright, that's your transversal, and it transverse A and B. So A and B are your parallels this time, and M is the transversal. Now these are on the exterior, and they're alternating exterior angles. Alright, so angle 12 and angle 14 are alternate exterior angles, okay, of lines A and B because angle 12 is congruent to angle 14 A is parallel to B by the, guess what, the alternate exterior angles converse. Okay? So when you do this assignment, to show your work, just whichever you put your drop down, what you put in order, that's just what you're going to write on your paper. And then we only have one more section of this unit that we will do when we get back, and so I'll be looking for my summaries when we do our study guide, so you might want to take care of those. All right, on the back. Now we're going to do a little math on the back. Now I will tell you that the math in the assignments is a little more than the math on this page. So I want to show you one thing that I showed you with angle relationships. We're going to do it over here. Okay? So I'm going to have this line. We're going to do a line parallel to it. And then it's going to be cut by transversal. Okay, so this is line A, line B, transversal C. All right, what you need to remember, because it will come in handy and reference this when you are doing your math problems, all right? So when you have parallel lines cut by transversals, you have 8 angles, but they only have 2 measures. You have one acute measure. All of the acute angles all measure the same. And you have one obtuse measure. All of your obtuse angles measure the same. So, if you have a pink and a pink, you're going to set them, and you're trying to find a missing variable, you're going to set them equal to each other. If you have a yellow angle and a yellow angle, you will set those equal to each other to find your variable. But if you have a pink and a yellow, you're going to add those up and set them equal to 180, because together these form straight lines. And it could be this yellow and that pink. They still equal 180, all right? So when you have one of each, so be mindful of that when you are doing your assignments, okay? So let's get to this one. So it says find the value of y so that E is parallel to F. Identify the postulate or theorem you used. All right. So we have this, and we recognize this triangle, this square here means that it is 90 degrees. Well, if this one's 90 degrees and makes a straight line, that means this one has to be 90, and this makes a straight line with that, that has to be 90, makes a straight line with that, that has to be 90. And well, if they're parallel, that makes all of these 90 as well. So we just have a whole bunch of 90-degree angles going on here. Okay, so it says from the figure, you know that line D is perpendicular to line E. That's the only way you get a 90-degree angle. It has to be perpendicular. For lines E and F to be parallel, line F must also be perpendicular to line D. All right. By the perpendicular transversal converse, if F is perpendicular to D, then 4y plus 10 equals 90. Solve for y. All right, so definition of perpendicular equals 90. Subtract 10 from both sides. Subtract 10 from both sides. That gives me 80. Divide by 4. Divide by 4. Y equals 20. Now again, the math is going to be a little more complex, but you can do it. All right, so I'm going to want to see the equations. I want to see you form the equations. I want to see you do the math. All right, think about it. Some of them will be a little trickier than others, so just be mindful of that. All right. Now, my last example, okay, I'm going to let you know this is a rowboat, and we have 2 oars, and it's not showing through on the video, but on the paper, definitely not going to do that in black. Let me see, pink. So we have an oar. All right, we have oars. And we have a boat. And we know this one is 50 degrees. And we know this one is 124 degrees. And we're going to see if the oars are parallel. Okay. So to move in a straight line with maximum efficiency, rowers' oars should be parallel. That's their goal. Refer to the photo on the right. Is it possible to prove that any of the oars are parallel? Justify your answer. Okay? So the angles that form a linear pair with the 50 degrees angle has a measure of, well, linear pair, that means it forms a straight line. So 180 minus this 50, what it is looking for, it's looking for this angle here, okay? And that would be 130 degrees. This would be 130. All right. So the angle measures 130 degrees. And that is the corresponding, okay, the upper angle, wait, if that's 130, that's 124, that doesn't match, okay? So the angle 130 is the corresponding angle to the 124 degree angle, okay? Because the corresponding angles are not congruent, meaning they do not measure the same, okay? The lines are not parallel, because in order for them to be parallel, they would have to measure the same. Therefore, it is not possible to prove the oars are parallel. So they are not rowing efficiently, all right? They need to do better, don't they? All right, so finish your assignment. Remember, starting quarter 2, once we test on the material, we will no longer be taking late work on it. And I had to split module 3 for geometry, so 3.1 through 3.7 is all on quarter 1, 3.8 through 3.10 is on quarter 2, but 3.8 through 3.10, the last day I will take any of those, I think it's 4 assignments because 3.8 was split into 2 days, will be the day we test, and that will depend on exactly when we come back and how far we can get, and if we have internet. All right, so good luck. Get your assignment done.